Okay, so it does get messy when you do the domain, so be careful here. It says the domain of sum, difference, product, and quotient functions consists of the x values that are in the domains of what? Both. The key word is both f and g. So if I want the domain of the answer, you have to look at function f, function g, and say, what do they share? Okay, watch this. Ready? Here's function f. Only positive numbers work. Here's function g. Anything works. All real numbers. What do the two groups share when I put them together? Positive. Only positive. So that's it. The answer is positive numbers. So that's what they mean by it. They must be in both f and g. Also, the domain of the quotient. What's quotient? Isn't that division? Yeah, right here. Look at division. The domain of the quotient function does not contain any x values for which g of x is going to equal what? 0. So when you look down here, guys, and you see that there is an x value that makes it 0, you have to tell me, don't let x be 4. Don't let x be 6. Because if I do, it's going to be 0 down there. Can you divide by 0? No. No, and that's why they say g of x on the bottom can't be what? 0. It can't equal 0. Okay, we'll get into that later. Let's get started. First, let's add, then let's subtract two functions. All right. All right, here we go. This is your first problem. Then your second problem. First problem, f plus g of x would be take your function f of x plus take your function g of x and go ahead and add it. Well, what's f of x?
Y.
2x squared plus 8. It's right here, guys. Look. What? And then it says add to it what?
G. X minus 3.
X minus 3. Well, if you're going to add two functions, it's pretty simple. How do you do it?
Just add the 3 and the 8 to equal 5.
At the like term.
Like terms. That's what I was looking for. Like terms. 2x squared is 2x squared. Are there any more x's?
No.
Just this one, plus x. How about the numbers 8 and minus 3?
Plus 5.
Plus 5. Done. Added two functions? Pretty simple. Add like terms. All right, now let's do it again. Subtract two functions. F minus g of x is the same as, take the function f, subtract the function g, and get an answer. Well, f is 2x squared plus 8. Now you're going to subtract what? G of x. But here's the problem. The problem is g of x is a binomial. So you've got to subtract everything. X minus 3, put it in here. Now how would you treat that minus sign in front of the parentheses?
You would
Did you say put a negative 1 there?
No.
Yeah, you can. Negative 1 times that. Negative 1 times that. I would have been happy if somebody would say just distribute it through, and somebody probably did. So it's what? 2x squared plus 8 what?
Plus 8, negative 1x, plus 3.
Plus 3? Okay. Now, add like terms. Once you distribute the negative sign through, you're good to go. Answer?
2x squared minus x plus 11.
Plus 11. What do you think?
Yeah.
Subtraction is not that bad, is it? Okay. All right. I'm sorry, I forgot this part. This is the part that I worry about for you guys. What are the domains of each answer? Now, here's to get the domain, you have to do this. You have to kind of start here at this function. What's the domain of this function? Okay, look at x, and look what we're doing to it. We're going to square it. If we're going to square a number, tell me what kind of numbers can be squared. Can I square positives?
Mm-hmm.
Yeah, you can square. Can you square negatives?
Yeah.
Can you square 0?
No.
Can you take 0 times 0?
Well, yeah, but it's 0.
You get 0.
Zero.
But you get an answer. As long as you get an answer, you can do it. So what kind of numbers can you square?
real numbers.
Any number. All real numbers can be squared. Okay, look at this one. What kind of numbers can you subtract 3 from?
Anything.
Anything. Yeah. So the domain is what here? All real numbers again. Well, remember what I said in your answer? Your answer is what these two domains share. All reals, what do they share?
All reals.
All reals. So the domain here is what? All real numbers. This one. What does this share? What does that share? All real numbers. There you go. That's it. That's all it is. You just ask yourself, what does this group share with that group? All real numbers. Somebody asked me last period, when is it going to be different? And I said never. Adding and subtracting functions is so easy. The domain doesn't really ever change. It's when you get down here that it starts to happen. Okay. This one says what?
F2's G
Of x. So that means take the function f of x and do what to it? Yeah, that's all it means. Okay. Well, copy down the two functions and then multiply. That's all it is. X squared plus x minus 6. Take that times what?
X minus 2.
Mm-hmm. Now what?
Distribute.
Yeah. Yeah, somebody said FOIL last hour or 2 hours ago. FOIL goes with binomial times binomial. So I like it, Ty, when you said just distribute it through. Right? Isn't that what we're doing?
Oh.
What are we going to get?
X cubed.
Followed by?
X squared.
Followed by?
Negative 6x.
Okay, that was easy. Now take the negative 2 and run it through. That's what?
Negative 2x squared.
Negative 2x squared followed by?
Negative 2x.
Followed by? Last one, this one.
Plus 12.
Plus 12. Okay. Hey, to me, multiplication is nothing but a lot of work. You multiply, then you add like terms. There are no more x cubes. That's it. X squared there, x squared there. What does that make?
Negative x.
3x squared.
Negative 1.
Oh, yeah.
This is 1. This is minus 2. It's negative 1 x squared. You don't need the 1. Negative. You don't need the 1. What else?
2.
That one.
Negative
Negative 8x.
squared.
Plus 12.
Plus 12. Done. That's it. Done. Oh, by the way, up there, if you look at the domain, what's the domain of this one? What's the domain here?
All real numbers.
Yeah, you can square anything. You can add anything to numbers. Yeah, this is all reals. What about this one? Can you what can you use? Can you subtract 2 from positives, negatives, and 0?
Yes.
Yep. Guess what? It's all reals, all reals. So what do these two groups share?
All real numbers.
All real numbers. So the answer down here is, what's the domain? All reals. Done. Good? All right. Here it comes. This is the hardest one of all. It's what? Division. F divided by g of x would be f of x divided by what? G of x. Let's write it out. Here we go. F of x is what?
X squared
X squared
plus x
plus x
minus 6.
minus 6. G of x is
X minus 2.
very few students,
X
very
plus
few
3.
classes have got this right.
X plus 3.
Is that a 3?
Well, no, I mean the answer.
Oh, okay. Okay, tell me what to do, Brittany. Tell me how do I attack?
The x's cancel,
Okay.
so that there's only one x left. Like the x squared, it would
Yep.
be 1x, and then the x's next to that would cancel, and then negative 6 divided by negative 2 is 3.
So the answer is what?
X plus
X
3.
squared plus 3.
X squared plus 3. He
No, it's
said
just x plus 3.
you say it's this, Ty, and you say it's
X plus 3.
this. That's what they're saying. Are they right?
X plus.
You know, so, Brittany is canceling the x's. And then she says that divided by that is plus 3. X squared is what Ty sees, so that's why he says it's this. Brittany, I'm not sure. Are you canceling this with this?
Mhm.
Oh. Are you guys okay with what they're doing?
That's where she went wrong, yeah? Right.
Nobody's saying anything?
Yeah.
I think I'm right.
Yeah? They're both wrong.
Ah,
They're
that
both wrong.
seems so
Here's the deal. She wanted to cancel right away. Ty's agreeing with her. He's doing all that. But here's the problem. You can only cancel when you see this. If you see this, you can cancel. Okay. If you see this, you can cancel. What I'm saying is, if you see multiplication over what? Yeah. Multiply over multiply, go ahead and cancel. That 5 once, 5 goes in here twice. How about these x's? Do they cancel? Sure, that one goes away. What's left? X squared over what? 2. Hey, you have multiplication over multiplication. Cancel away. Problem is what? Did you have multiplication?
No.
No. You have what?
You're supposed to addition, subtraction, but you divide.
Addition, subtraction. You do not have it. So now I got to ask you this. I got to ask you, how do I attack it out? Multiply by the opposite. No. No. I need multiplication so I can cancel. Do you guys remember what?
Oh, do you multiply by the reciprocal
No.
conjugate?
No, that's what he's going after. Here's the deal. You guys, I said you can only cancel when you see multiplication. Do you guys know that factoring is turning a problem into multiplication? So what if I asked you to factor the top? Factor the top for me, will you?
X plus 3 and X minus 2.
X plus 3 times X minus 2 times, look, you have multiplication now. Factor the bottom for me, will you? Can
X
you?
minus 2. It's just
No,
X
you can't. So what you have is X minus 2 on the bottom. You have a binomial on the bottom. Look at this binomial. Look at this binomial.
Handful.
Here's the deal. I thought I said you need multiplication here. Where's the multiplication?
There isn't.
Yeah, there is.
Oh,
One times X.
It's basically this. This binomial times what? 1. There. There is multiplication there. Now go ahead and do what? Cancel, cancel. What's the answer?
Isn't that what I said
that
though?
was right.
X plus
Yeah.
Oh, you're wrong.
What you're doing is all wrong, just so
Okay.
you know. I mean, you got lucky that it actually came out to that. That's not right. What you might have worked on this one, and that's a terrible problem. I should probably take it off for next year. That is not what you want to do. Do not cancel. Promise it won't work. Okay, and you kind of did there, I guess, yeah. Oh, what's the domain?
All real numbers.
All real numbers is what they shared, right? There is a problem here, though. It is all real numbers except for one number. Go back up. Right there. Look right here. This is where we say, don't let this number down here be 0. When would this number down here be 0? When x is?
2.
2. So you know what you say in the end? I can plug anything into my function except what?
2.
Except 2. I can say, comma, don't let x be 2. X cannot equal 2. Anything works except 2. You okay with that? You see why 2 can't work? Because if you put 2 into the original, you're going to get undefined. Okay. Next. Not doing it. Okay, we just did it. We don't need to do it again. Next. This is the one I call them composite functions. They call it a composition of functions. This is kind of different. This is you doing this. Take a function, f of x. Get an answer. Whatever you get for the answer, stick it into the other function, g of x. Okay? That's what you're doing. Right here it says g of f of x Oh, I should have read it like that to you. Sorry. Let me go back up here. The composite of functions g and function f is written like this. How do you read that?
G times F.
G times f. That's how you read it, don't you? Because you see that circle and you think it's a time sign, that's an indicator that it's not a time sign, because circles in math are going to be
The word of.
It's g of f of x. So this is telling us to take the function f, get an answer, stick it into function g, get another answer. It says n is defined as g of f of x, and they write it like this instead. This is how I always write my composites. G of f of x. I'm not talking about the domain here. Okay? Now when you do write it like this, guys, g of f of x, what they try to tell you here is this. First do what function? F of x. Evaluate f of x first, get an answer. Then, second thing you do is then use the answer as what? As an input for g. So you take the answer for f and you stick it into g, you get out another answer. That's all it is. Let's go down here. Okay. Hard to see what I have here, but I think this says f of what?
X minus.
F of g of 3.
Negative 3.
F of g of negative 3. Okay. So this is what they want you to do. Here's f, here's g, and do that. The way I write this is I go like this. Take the function f, get an answer when you know the answer to what? Function g when x is what? Negative 3. That's how you do this. You have to do it twice. You get an answer, then you get another answer. Okay, the first time you do it, you'd stick negative 3 in for function g, which is right there, by the way. So you would say what? What's g of negative 3?
Negative 3x squared.
equals x squared.
No.
Negative 3x squared.
Negative 3 is the x value you put in g. So you put the negative 3 in for x and you square it. Negative 3
Oh, so it'd be
squared
9.
is what you do. You're doing what g tells you to do. So that's going to be f of what?
9.
9. The answer to g of negative 3 is 9. Now you take the 9 and now you stick it into function what? F. Go find f.
Wait, what happened to the x minus 5 for that?
Oh, I haven't even got there yet. Look, it said work with g, didn't it? Work with g. Put negative 3 into g. There I go. I'm putting it in. Well, negative 3 times negative 3 is 9. Now take your answer and plug it into what function? F. Well, where's f? Right here. So you would put a 9 in,
So,
and then you would
x
subtract 5 and get what?
4 x. 4.
There's your answer. You get an answer for g, then you stick your answer into f, you get an answer for f4, and that's the final answer. Right there. You're done. That's probably one of the first composite functions you've done. The next one says do what? Can hardly see it. G of
Of f.
Negative 3.
negative 3 again. Okay, that's your next problem. Where are you going to start? What function?
Negative 3 minus 5.
Yeah, but you're starting in function f, aren't you? Go to function f, stick the negative 3 in. Well, if I stick the negative 3 in, it says what?
X minus 5.
Right here. Negative 3 minus 5. Okay. What's that?
Negative 8.
That is negative 8.
Then we have to square it for
And then
g,
you have to put negative 8 into function g,
which is x squared, so it'd be negative 8 squared.
which is right here, x squared. So take x, negative 8, square it.
64.
64 it is. Good?
Mm-hmm.
Okay.
So
How about it?
what's equal 64?
What equals 64? G of f of negative 3. So when I started this problem, I said, what if x is negative 3? Well, if I put it in F, I get -8. If I put -8 into G, I get 64. Okay, guys, do the next one on your own. It's right here. It's G of what? G of F of. I can't read it. -2. Is that where you plugged it? Right there? -2 gets plugged into F. F is x squared plus 1. So if I square x, add 1, what's the x and plug it in? There you go. What's -2 squared?
4.
Plus 1? 5. So when you plug -2 into F, you get 5.
So G of X.
Now you plug 5 into G. G's right here, by the way.
5 minus 2 is
Yeah,
3.
that's 5 minus 2. Answer's what? 3. Good?
Can I go to the bathroom real quick?
No, I want you to stay here, because this is where it really gets weird. What does this one say? Right here.
G of G.
G of A. They're not telling you to put a number in, they're telling you to put a variable in. So this time when you put a variable in, let me get kind of ready to sign this. Okay, here we go. Put the A in for G right here. Okay, guys, tell me what it's going to read now.
A minus 2.
A minus 2. Yep. Instead of putting X, you're going to put what in for X? A. A minus 2. Now you got an answer. Because this, can you do anything to this?
No.
No, you can't do anything. A minus 2. So now stick A minus 2 into what?
G again.
G again. Here I go. I'll draw another arrow for you. In for that X, what are you going to put?
A minus 2.
A minus 2. But wait a
Minus
minute.
2.
There's another what behind that X?
-2.
A minus 2.
So it'll be 8. So
A
negative
minus 4.
A minus 4. That's the answer. Those get kind of weird when they tell you to stick a variable in for a variable. I get it. That looks weird. But the whole thing worked out kind of weird. Okay? Now, where do we use this stuff? Okay. We use it right here. Right here. Story problem, let's use it. Using composite functions. You got a store? Let's say Menards. Menards is offering a 15% discount on all gallons of paint. How much do I knock off? 15% off. Okay. Then the manufacturer is also offering a $3 what? Rebate on each gallon of paint. What's a rebate?
A refund. So
Yeah, so if paint costs $20, what happens?
you're getting $3 off.
So what did it cost you?
17.
17. Okay, so either you get that or the other one, 15% off. So now they say this: write a function f of x, okay, f of x, to represent the price of a gallon of paint after the cash discount. And by the way, what's the cash discount?
$3.
No.
15%.
The discount was 15%. You're going to get 15% off the paint. Okay, well the question becomes, what did the paint cost you per gallon?
We don't have it.
Okay, we don't know what the paint cost, so shouldn't we say something like cost per gallon is what? If you don't know, call it what?
X.
Call it X. I don't know what it is, it's X. Okay. Well, you're getting how much off?
0.15.
15% off of that price. So what did you write a function to represent the price of a gallon of paint after the cash? So we want the price. How much did it cost? You got 15% off that number.
0.15 times X.
Okay. Wait a minute, Brittany, hang on. I want to show you something here.
That would give you what you got.
Okay, let's pretend paint costs $20 a gallon. You got 15% off. 0.15 times that equals That's what you got off. That's not what this said. This said, what are you paying for it? That's what you got off the gallon of paint. What did you pay for it? And I know you're going to tell me $17. I get it. But how could I get... I know the answer is I paid $17, but what would give me that? That's 15% off. If you got 15% off, what'd you pay for? You paid everything for the paint. Everything. You paid 100%. You knocked off 15% and got $3 off. What did you actually pay for?
Same are 85%.
80 what?
85.
85%. Guys, if the paint costs 100% to begin with, and they knock off 15%, you only paid 85%. So this is what you paid for the paint. That's what you paid. But wait a minute, we don't know that it was $20. We know it's what?
X.
And we think it's X. So let's go back here and write what? What did we pay?
0.85.
That's what you paid. That's your first function. What's your second function? Write a function g of x to represent the price of a gallon of paint after the $3 discount. Say it.
X minus 30.
Yes. Here's the cost of the paint. My rebate will give me $3 back. I'll just subtract 3 off the gallon. Good? Okay, we're getting there, guys. C, suppose a list price of a gallon of paint is $45. Hey, I know how much the paint costs. $45 a gallon. Use composite functions to find the price of a gallon of paint if the cash discount is applied before the rebate. So the question becomes, what happened first? What did they do to the paint? Did they do the discount or did they do the rebate first?
Discount.
Yeah, it says the cash discount is applied before the rebate. So the discount was F of X. Then they did what last? The rebate. We called that G. Do you get what just happened? What was the cost of the paint? $45. There you go. So there's your problem, everybody. It's G of F of 45. So what do you do first to the 45? What do you do? Do you subtract 3 from it? Or do you take it times 0.85?
Minus
0.85 times what? $45 gets you what? 30 what? Did I hear you say 0.25? Okay. Now what do?
Plug that in for G.
Plug it in for G. G's right here. I can see G right there.
So minus
So 38 what?
38.25.
Minus 3. What is the final cost of the paint?
35.25.
$35.25. Perfect. So that's what you get if you apply the discount first, rebate last. The next one is just opposite. This time, the rebate is applied before the cash discount. So now they want you to do what composite function?
G. 45 minus.
Well, rebate first. Isn't that G? G of 45. And then what's last? The discount. That's your function F. So there's your composite right there. This would give us what? 45. Take away the rebate. 42. Apply F.
45.7. So
Well, don't you take 85%?
$35.70.
30 what?
$35.70.
Good? That's it? We made it, we got to it. It sure helps when Selena sits in front and Victoria sits in back and Ty behaved himself, he did a good job today. Good job, Ty. Brock wasn't giggling. Brock fell asleep though, but whatever. And look at Allison, she just passed out on me.
Tired.
Your brain just explodes.
Once your brain explodes, your eyes close.
Your brain exploded.
I don't know what brain cells are left.
What am I putting them in? Did it already.
Fuck you.
Oh, we're not? We're not in? Oh, you guys.
It's because I was
Hey,
singing it out loud.
you guys never got your quiz back, did you?
Yeah.
Sometime. I don't know what time it is, I can't tell.
I kept saying,
Here goes. Here goes. These are not in the computer, just so you know. Allison, Nick, Rock, Elsa, Haley, Hannah, Rock, Brittany, Bryce, Carlos, Jessica, not here, Victoria, right there, Patrick,
Yes.
there, Josh, Isaac,
Carlos.
Selena, Cole, not here, Cedric. That's it. Is it?
There you go.
I'll take them. You're done.
Hey, if it was an 83.7,
I don't do any of them. Like when the school year's over. When the quarter's over, then I know. Right now it's exactly.
Why?
There you go.
Why? I actually don't know what.
So, but you switch around, you know what your hypothetical in this class that you get this quiz in right now, is that gonna get it to a high F or a high E? I mean, a low E.
I don't even know your grade, but
It's 36.
36.
Yeah.
Wow.
I think
I was just a little.
I like it.
Is that in power school?
See, I didn't know.
Did he
He
say
said
I
no,
didn't know
I
I
said.
was today. I
He
No.
said
didn't
that's in power school.
Not in power school, I have a time. It will be. When I get to it.
Here.
Rock, is your game canceled? Yeah? Too cold?
First game was colder than this. First game was like 15 degrees.
It's so weird how many grades it goes.
Like 35 degrees.
35. Oh, that's pretty.
It's sunny and it's not raining.
Yeah, I know. Once you guys play 8 at night.
Oh, yeah.
Yeah, I got cold. I got 44 degrees.
That's just yours.
It's weird. Did they cancel?
Where's the brain cells a lot?